Hello everyone, welcome to this video where we're going to cover 3 of the new language features that were included with Java 14 as previous. We're going to cover records, pattern matching with the instance of operators, and text blocks. So let's get started. Okay, so in IntelliJ, I already have a project that I've already prepared with a couple of examples to show you the 3 topics. Before we actually begin, one of the things that is important to check is that because we're going to be using preview features that are included in Java 14, is that we need to tell IntelliJ that we want to use those features. So you have multiple ways of doing this, but the approach that I usually take is I go to File and Project Structure. And over there, when you go to the project settings, there is a language level that you can select. In my case, I already selected 14 preview. And this basically tells IntelliJ that we want to use the preview features that come included in Java 14. That's basically records, patterns, and text blocks, which are the 3 topics that we're going to cover today. By default, if you're using Java 14, it's going to select you the non-preview version of it, which is what it expects most people to use. But in this case, we want to use the preview features because we want to start experimenting with them. So you can click on that and click on OK. Now, if you're using a Gradle project, as I am in this case, I'm using Gradle to build my example project. You also need to tell Gradle that you want to add the enable preview compile argument to the Java compile tasks. This is the argument that tells Java, the Java compiler, that you actually want to use the preview features that come included in the JDK. I'm also doing the same for the tests in case that you have tests. In the current example, we're not using unit tests as such, but this is the way that you would enable them in case that you need it. The last thing to bear in mind is that when you're running your project, you need to, in the VM options, you need to add the enable preview option as well here, such that when it's running, it also tells the Java executable that we want to use the preview features of Java 14. Cool. Okay, with that out of the way, you should have everything ready to be able to use the 3 features that we're going to check, which are preview features. So the first feature that I'm going to show you is actually records. So for the records example, I'm going to start by explaining what I have prepared to give you a little bit of an overview, a bit of context of what we're going to check today. So I have a main method over here, and in my main method, I'm making use of a class that I call user. And the user class for this particular example is a very, very simple class. It just has a name of the user, and it has a couple of fields that represent the phone number of that user. You're going to see that I have a type, and this type is basically an enum, which tells me, okay, if it's a home, mobile, or office phone number. I also have the code, which is the actual country code of that phone number. And yes, if you're wondering why I called it code instead of country code, you're going to see why in a couple of minutes. Of course, country code is a better name, so it's just for the purpose of the example. And the actual phone number, right? And I have the usual getters and a couple of setters here, just for the purpose of the example. And I define my equals, hash code, and 2 string methods for the user. Cool. Nothing fancy here, just a basic user class for the purpose of the example with a couple of fields in there. Now, for the purpose of this example, what we want to do is we want to change the user class such that these 3 fields actually belong to a phone number class, right? Because these 3 belong together, right? They represent a phone number for a user. The usual approach, of course, is to take this and move it to a separate class, right? So you're going to see that I have a package here called classic, and this would be like a classic approach of doing it. By no means is the only approach, but this is one way of approaching that, right? And this is pretty standard, right? I think if you've been doing Java for a while, I think this is very common to do, and you know that the IDE is going to provide support to basically do most of these things actually. I mean, it's going to create the getters for you, it can create the equals method, and it's going to create the hash code method as well for you. And we're used to this. However, one of the things is that this can be very verbose if all we want to do is basically a data carrier that is going to hold these 3 values together, right? In other languages, this is called a named tuple. So I have a tuple of 3 fields, a phone type, a code, and a phone number. And this tuple is called a phone number, right? And this is where records come in. It's a way that Java is going to provide to us to provide a more compact syntax to declare these classes that are basically data carriers, right? My phone number is just basically a value object that is going to carry these three values around. So let's see how this would look using records. So I'm going to open the second approach that we have, which is I'm going to define basically the same phone number, but using the new feature in Java 14. Again, it's a preview feature using a record. I'm going to put it side by side so that we can compare. Now, the first thing that you're going to see is that now we have a record type declaration here. So we can say, okay, this is going to be a record type, which we're going to call phone number. And we're going to tell Java that we want these three fields to be part of that phone number, right? So it's basically exactly what we have here in the constructor is what we're going to put here in our record declaration. And this is basically the components of our record. Internally, it's going to do something very similar to what we have on the right-hand side. It's going to internally create a class that extends the record class from Java that has the three fields, and it's going to make them final as well. It's going to create a constructor that has the same fields that we provide in the record declaration, and it's going to have them in the same order. It's going to create accessors like getters for these fields, but we're going to see in a second one of the differences between records and the usual way that we handle these classes. And it's also going to provide a default implementation of equals and hash code. And this is basically the syntax. So this is going to end up looking very similar to this internally, and we can use it as a normal Java class because that's what it becomes behind the scenes, right? The compiler is going to turn this into an actual Java class behind the scenes. So let's take a look at and see how this is going to be used. So if I go back to my main method, I'm going to create a new phone number. I'm going to say, okay, I want a new phone number. I'm going to use the record one, so the one that we just created. And I'm going to pass it a type, a country code, and a phone number, right? So here I'm going to say it's going to be a mobile phone. Let's say that is a US number, and it doesn't really matter what number I'm going to provide to it. And that's it. Cool. So a couple of differences between what we're used to using the getters and what the records provide to us. So I can define a variable to hold the country code, for example. So internally, the record is going to provide us with methods that have the same names as the fields that we provided. So in my case, I have phone.code, and this is going to get the code field from my record. So this is why I wanted to highlight, and this is the reason that I use code instead of country code in the user class. What is it that I'm trying to show here? In my user class, even though I called the field code, the getter for that field, I called it get country code. So the API that I'm exposing is something that I actually have control over, right? So my API is separate from the data or from the fields that I declared in the user class. So I could have called this C or A or B, it doesn't really matter. The API that my class, my user class is exposing has a proper name, it's get country code. So it's a complete separation between the fields that I have and the names of the methods that I want to provide. In the records classes, I give up that flexibility. I give up that flexibility of saying, okay, my internal fields are going to be called whatever I want, and my public API is going to be called something different. When you're using records, you don't have that flexibility anymore, and it's something that you have to give up to get some other things in return, right? So in my case, I don't want this to be called code because it doesn't mean anything really. I mean, code could be anything. So I want this to be actually called country code. And you're going to see that IntelliJ already identifies this. And when I go to my main method, it's already renamed the method call that we have here. So this is the only reason I call that variable code, is just to highlight that the names of the fields that you put here are very important, and it's very important that you name them properly because these are going to become your API, right? So the API of your phone number is based on the name of the fields that you provide here. Cool. Okay, so I'm going to close the classic one now, and let's focus a little bit on things that we can actually do inside of a record declaration. In general, records behave like classes would do, but they have certain restrictions. For example, in a class, I can declare fields. So I can put here, let's say, the name of the phone number, if the user wants to give it a name, for example. This is something that I cannot do. Inside of a record type, I cannot provide instance fields anymore. All the instance fields that I want the record to have should be provided in the record declaration. So this is something that I cannot do. However, I can use static fields. So I can provide a static value here. So let's say that we want to store here, I don't know, the minimum phone number length. And let's say that we want phone numbers to be a minimum of 5. So I can provide a static fields as we do in other Java classes, and that's perfectly valid. What other things we can do? We can define extra methods or extra behaviors for a record type. So we can provide methods here. So I can say public void. Let's say that we want country code with number, and let's make this a string. And I want to return the country code with a space concatenated with the phone number. Yes, for the purpose of the example, right? And again, we can do that. We can add instance methods to a record type. What other things we can do? So as we saw in the main method, and as we mentioned before, the records provide us with a constructor that has the fields that we provide in the record declaration. We can define extra logic for the constructor of the record. And we can add, for example, validations to the inputs that we get in the constructor. So let's take a look and try to generate a constructor in IntelliJ. You're going to see that IntelliJ tells us that records support compact constructors, a canonical constructor, and custom ones. So we're going to start with the compact constructor for a second. You're going to see that this doesn't look like your usual constructor. I mean, it does have the name of the class, so that makes it a constructor, of course, but it doesn't have any parameters. So this is what is called a compact constructor, because it knows that basically we want to define extra behavior for the constructor that has all of these parameters already, right? So we don't have to repeat ourselves, and we don't have to put this here again, right? And you're going to see that these fields that we have over here are accessible from our compact constructor, and we can start checking them. So for example, we can verify that our type is not null, right? I want the phone type to always be provided. So let's say that the phone type must not be null. And this is an example of how to add a validation to that phone number. Excellent. So that's the compact constructor out of the way. Now we can also provide, as you saw, what is called a canonical constructor. And the canonical constructor is basically the same as the compact constructor, but we want to add all of the types that were also defined in the record declaration. You're going to see that IntelliJ tells us that it's a redundant canonical constructor and that we can remove it because it detects that it's doing the same that we would do normally, right? So again, what we want to do here is I want to add this validation, and I want to say, hey, I want to verify that the type that is being provided to us in the constructor is not null. Now, IntelliJ is also telling us that, hey, what you're doing here, it's redundant. You don't need to put all of this again. And it's suggesting to us that we should turn this into a compact constructor. And I'm going to leave it like that because that's really what we want to do. Cool. Now, we can also define our own custom constructors as we do with other classes, right? So I can provide a phone number. And let's assume, just for the purpose of the example, that we only want the country code and the phone number to be provided. And basically, this is going to force us to call the canonical constructor, right? So I can call these. And let's assume that what I want in this case is I want to default the phone type to be home and pass the country code and the phone number. And that should work as well. Okay, so we can also provide custom constructors if we want. The only condition is that we need to call the canonical constructor from that point. Excellent. Now, another thing that you can do is, as I mentioned before, actually, let's leave the phone number validation because I want that. Another thing that we can do with records is that we can override the default implementations of some of the methods that the records provide to us out of the box, right? So we can provide, for example, getter, and IntelliJ is going to give us, okay, you can provide getters for these three types. And let's say that we want to override the three of them, right? You're going to see that in a record class, we don't get the get prefix on them. As I mentioned before, it's going to have exactly the same name as the name that we have in the fields. And we can override if we wanted, or if the use case that we have forces us to override the getter implementation of these types, we can do that as well. In addition to that, we can also override the equals, hashcode, and toString methods. Remember that those have default implementations that are, in most cases, I would say, the implementations that you actually want. But if they're not, you can actually override them. And I'm asking IntelliJ to do it for me for the equals and hashcode method, for example. Just remember to follow the equals and hashcode contracts if you're going to override them. Just make sure that you're following the contract that is defined in the object class. Couple of extra things that are important to mention about records. First is that a record is going to become a final class in Java, so you cannot extend a record class from another class. The second thing is that record classes cannot be abstract, so they're concrete by default. And the last thing that is important to note is that records can actually implement interfaces. So if you want a specific record to implement an interface, you can do that as well. Okay, cool. So the last thing I want to show you before we actually go to the user class and modify it a little bit for the purpose of the example is to show you the compiled version, or well, the decompiled version of what Java is generating behind the scenes. So I'm gonna go to the classes that were built for this project. And we can see here what we were talking before, right? And we can see that the phone number record is turned into an actual final class that extends from the record class from the java.lang package. And it includes the three fields that we define in the record declarations. We have our type, country code, and phone number. And the three of them are marked as final. It provides us with the canonical constructor with the three fields that we provided in the record declaration. And it provides the implementations to the methods that we discussed before. So we have the toString, hashcode, equals, and we have the three accessor methods, type, country code, and phone number. It's not showing me the bodies of the methods, but that's not relevant at this point. I just wanted to show you a little bit of what a decompiled record class looks like. Cool. So I just want to show you, of course, how to use now a record class inside some other data type that you have. In our case, our user class. Now, of course, what I want to do here is instead of using these three fields, I want to use the record that we just defined. So I'm using the phone number from my record package, which is the one that I was showing you earlier, and I'm going to call this phone number. And again, you can use it just as any other normal Java class that you have, right? And I'm going to have a phone number assigned here, right? I'm going to assign it to the user. And of course, these three methods don't make sense anymore. I'm going to actually redefine this, the equals, the hash code, and the toString methods as well. I'm going to get rid of all of these. I'm going to create a getter for my phone number. So I have my get phone number as well. And I'm going to create the equals and hash code methods for the user class, now using my phone number as well. And I'm going to create a toString. Actually, no, I don't need the toString now at the moment. Okay, so as you can see, what I'm doing here is just basically using my record class or my record type as you would do normally with any other data class that you have in Java. And it works perfectly fine, right? Now, what I'm going to do here is I'm going to use that phone number and pass it to the user that I'm creating, right? And here I can say user.get phone number, and here I can get a country code, for example, and I can assign that to my country code variable, and I want to print that country code to the console. I'm just doing here a quick example, and I want to run this. Cool. You're gonna see that it failed, and I'm gonna explain to you why in a second. But what we can see here is that it's actually printing the country code as I expected. So +1, +1. And again, I'm just showing that you can use records as you would do normally in Java. It's just providing us a very compact way of defining the usual data classes or data carriers that we create in Java in I would say, an easier way to do it, or a shorter way to define our data carriers. Now, why did it fail? So as you can see here, I'm using JSON at the moment. So all I want to do is just provide an extra example of things that you usually do with data classes, and it's just to serialize them into different formats. So I wanted to give it a try with JSON to transform my user object into a JSON object, right? So I'm using JSON for it, and the error I'm getting is because JSON says, okay, I didn't find a serializer that is compatible with that phone number record that we have. The main reason that a record like this is gonna fail for you is because JSON is not really detecting anything that it can serialize at the moment. Why? Because records don't use the normal getters that we use in other classes, like we do, for example, in the classic approach where you have get type, get country code, and get phone number. This is something that I understand it's being looked in JSON at the moment, and I could be wrong, so apologies if there is some extra news that I haven't heard so far. However, there is a very easy way to start or to be able to use JSON as a JSON serializer for record types. The main thing that you need to tell JSON is, hey, the actual way to serialize or deserialize this record is by using the fields instead of using the getters, right? And an easy way to do that is using the JSON auto-detect annotation. And here I can say that I want to use field visibility of type, of type any. And let's give that a try again. So if I run this again, now I didn't get the failure. And you can see that here where I'm printing the JSON object is printing the user object with the name and the phone number, which is my record, serialized to JSON as you would expect. And excellent, that was an introduction to records in Java 14. And now let's move to the second topic that I want to show you. So the second topic that we're gonna cover is pattern matching with the instance of operator. So here I have a pattern matching example already prepared. And I'm gonna again explain a little bit what we have and then go into details about what's happening, right? So for this example, I have an interface that is called shape, and don't worry about the draw method at the moment. And as you would expect, I have a couple of implementations of that square. And just for the purpose of the example, I'm using records, just to use what we saw in the previous section. And I have a square that implements that shape interface. And I also have a circle that implements that shape interface. And that's basically what I have in terms of the classes that you're going to see in the example. Nothing fancy. A circle has a radius, a square has a side. Now let's look at this pattern matching example class and see what the pattern matching with the instance of operator is about. So let's assume that in my main method here, I'm creating a shape. In this case, I'm creating a circle. And I have a method that is meant to calculate the area of the shape that you provide, right? I called it without pattern matching just because we are not going to use pattern matching in this specific method to actually see the difference between the two approaches. I'm going to hide this method for the moment because it's going to be the second part of this example. If you've been using Java for a while, you've possibly seen this pattern before, right? Where I check if a certain object, which I'm receiving here a shape, I mean, I don't know if it's a circle or if it's a square, I don't know what type of object it actually is. With instanceof, I can verify if that shape is of instance circle or if that shape is of instance square, for example. Now, what we usually see as Java developers when we have an instance of operator, and this is not a general case, but most of the times what happens is if I verify that this shape is of instance circle, let's say that this is true, the next thing that we're going to do is cast that shape to an actual circle type. to be able to use the properties or the methods that come from that class. So in my case, I'm using the radius to calculate the area of that circle. If it's not a circle, I'm doing the same for the square, right? So I'm verifying if my shape is of type square. And if it is, very similar to what I have in the other block of the if statement, I'm just casting it to the type that I just verified. So if it's of shape square, I'm casting it to a square type over here to be able to calculate the area in that case, right? Now, this is a bit more verbose than it should be, and this is where the new pattern matching with the instance of operator comes into place. So I'm gonna now expand the calculate area. Again, these two methods are doing exactly the same. It's just a very small difference, and that's the pattern matching with the instance of operator. What that operator is gonna allow us to do, or what that pattern matching is gonna allow us to do, is basically simplify these two lines of code over here and put them in the same line of code, or in the same expression actually. So in my first condition, I'm checking if shape is of instance of circle, and I'm already providing here the identifier that I want to have available if this condition is true. So what I'm telling it here is I'm checking if the shape is of instance circle, and if it is of that type, I'm telling Java, hey, already create an identifier called circle that is already the casted version of that shape. Very similar to what we're doing over here, but just in a single expression. And again, the next line is exactly the same. I'm just calculating the area of that circle. And the same goes for the square example, right? So I'm saying if shape is of instance square, I want to create already an identifier called the square that is going to be casted as expected. And that's basically the pattern matching with the instance of operator, right? So this is basically what it is about. And now if I run my example, you're gonna see here that it calculates the area of the circle with the classic way, let's say, of doing the instance of. And here in the calculate area of the square is using the new pattern matching for the instance of operator. Okay, cool. There is an extra thing that I wanted to show you, and it's about the scope of this variable that is created when using the pattern matching with the instance of. So let's go to the second example over here. So in this example, I have a square field, right? It's a static field. And you're gonna see that in the method, I also have an identifier in the pattern matching that is called square. So I just wanted to show you what happens in that case where we have identifiers with the same name, right? Of course, if you're using an IDE like IntelliJ, it's already gonna give you the hint about what square it's actually using in the different parts of the code. So it makes it a bit easier. But I want you to understand what is happening a bit behind the scenes, right? So when I call this method and I provide a shape to it, if this condition is true, right, if the shape is of type square, then this variable comes into the scope, right? So I can start using that variable only when that condition is true. So what is going to happen inside of the if statement is that this variable is going to hide the variable that comes from the class, right? So here, as IntelliJ is already showing us, is using the square that is coming from the if statement. Now in the else block, of course, this condition wasn't true. So this identifier isn't available anymore. I cannot use it over here. So what is going to happen is, of course, that this square is actually referring to the square that comes from the class. And I wouldn't suggest naming things that are going to have this class because it can create confusion, especially think about if you're doing this in a PR, in somewhere that doesn't give you this ability that IntelliJ is providing to us, or that an IDE is giving to us, that it's basically hinting us or telling us what is happening. I just wanted to mention that because I feel that's an important thing to know behind the scenes. An extra thing that you can do is that, again, this square identifier, this square variable, becomes available as soon as this is true, right? So I can actually append, let's say, an AND statement and say, hey, AND square dot side is greater than 5, for example, right? Again, because in the case of the AND, it already knows that this should be true, then my square is already available here because Java knows that this is this identifier, this variable, is available over here. So it's using the same variable in the three places. Excellent. Now let's take a look now at our third topic, which is basically text blocks. If you've tried to do text blocks before, and in this case I'm using HTML as an example for the first two implementations, I'm going to hide these methods for the moment. You're going to end up with something that looks like this, right? So here what I'm trying to do is I'm trying to render or generate an HTML template that just basically has a head, a title, and a body, okay? Nothing extraordinary, but if you've done this before, you know that this is a pain, right? This is not ideal, and if, of course, HTML might not be the best example because there are excellent templating engines that you can use. This is just for the purpose of the text blocks example, right? But what you tend to see here is that you need to add, of course, break lines by hand, and if you want it to look a bit better, you actually break the code or the string into separate lines. And again, there are different approaches to do this, but at the end, you end up with something that looks something like this, and it becomes very, very difficult to manage. So what are text blocks in Java? Text blocks are a way to provide this kind of, well, blocks of text in an easier way. So text blocks in Java start with three double quotes. So this is called the opening delimiter, and they end up also with three double quotes, and this is called the ending delimiter. Between the two delimiters, you put the text that you want to have, right? If you're in an IDE like IntelliJ, you're gonna notice that when I create a text block, it's gonna show me this green line over here, right? This green line is basically showing me or depicting where or what it identifies as the incidental white space that is gonna be ignored, right? So IntelliJ is basically telling me, hey, this text block, actually I'm only gonna consider it from this green line onward. And this is great because text blocks in Java, so it's going to be inside of Java code, and the Java code, of course, has its own indentation to have it, well, look proper, I mean, like properly formatted code. But in general, I don't want those initial lines to be part of my text block. And the text block implementation in Java is aware of that, and this is what it calls incidental whitespace. Now, how is that incidental whitespace calculated? It's going to take all of the non-blank lines that we have in our text block, and it's going to look at the common white space between all of these lines that are not blank, including the end of line delimiter, right? The starting delimiter is not taken into account in this computation, only these lines over here that are not blank. So for example, if I have a blank line over here, this isn't included in that calculation. So let's take a look and see what happens if I move, for example, this end delimiter a little bit to the left. You're going to see that green line or that green delimiter starts moving. And of course, my text block is going to change as a result of that, right? So now my HTML block is going to have three spaces prepended to it as well as all of the other lines. Okay, so that's an important thing to bear in mind when you're using text blocks. But this is a great advantage in the sense that you can control how that incidental white space is going to affect you. Now, these two examples, this classic way of doing the template and the new way of using the text blocks, in these two examples, they're going to render exactly, or they're going to generate exactly the same string, right? So I'm going to run that code for a second. And here we can see that we have the classic way of doing it, and the one with the text block. Well, I added this space for the example just now, but it's exactly the same. But I think you would agree that this is easier to manage if you have to do text blocks in Java. It's easier to do it this way than this way over here. Cool. Now, there are a couple of rules or things that you need to know when using text blocks, right? So I have this extra example that I want to show to you. And in this case, these two lines, actually what I want to tell Java is I wanted to treat it as a single line of text, right? I'm just breaking these two lines down for readability purpose of the code. But in reality, I want, in the string that is generated, I want these two lines to be part basically of a single line, right? And this is where this backslash escape sequence comes into play. So putting this backslash at the end of a line is going to tell Java, hey, I actually want you to concatenate the lines that are following, right? And you can, of course, can do it multiple times if you have multiple lines of text. that you wanted to treat it as a single line. Now, the second thing to bear in mind is that you can see here that I have extra white space at the end of this line, right? By default, these extra lines of text are going to be ignored by the text blocks. So any additional white space that you have at the end is not going to be taken into account. It's going to be ignored completely. There will be times maybe where you actually want that trailing space to be taken into account. You don't want it to remove it. And that's where this \s escape sequence comes into play. If you don't want Java to ignore that trailing space, you can add that \s, and it's gonna keep that space, or that additional space that you have at the end of the line, right? So if we check the example when I run it, you're gonna see that I have my string template, which is this one over here. And as you can see, these two lines were basically turned into one because I have the \escape sequence. In this line over here, if I start going to the right-hand side, you're going to see that it kept the trailing spaces as I wanted. And in the line below, I also have trailing spaces in my code, but because I don't have this \s at the end, so when I go to the end, there's nothing there, right? It doesn't have any extra space over there. Excellent. That's basically the introduction to text blocks that I wanted to provide. And again, this is a preview feature in Java 14, but I want to talk a little bit about what's going to happen in Java 15 to some of these features and what you can expect based on what is currently published in the OpenJDK website. So basically, to recap very quickly, in the tutorial today, we saw an introduction to records, pattern matching with the instance of operator, and text blocks. Now, Java 15 is very close to coming out. It's going to come out in September 15, according to the schedule that I see in the OpenJDK website. And they've already announced in that page what can we expect from these three features that were included as previous in Java 14. You can expect text blocks now in Java 15 to actually become a permanent feature of the language. Now, for records and the pattern matching preview features, they're going to continue being preview features in Java 15, in JDK 15, that is coming out according to the schedule on the 15th of September. However, something that is worth taking a look at in Java 15 is that we're also going to have a preview of sealed classes. And sealed classes play very nicely with records. And I suspect, and I want to see what's going to happen with the pattern matching as well with these two features. So again, as with all preview features, remember that anything that is in preview can change in future versions of Java. Sometimes things can disappear. I don't expect records or pattern matching to disappear because they're, to my mind, they're going to become very important features of Java going forward. However, they can change based on the feedback that the community provides and based on the use that we see of those features. In particular for records, I think we need to see how they're going to start being used by the community, see what patterns start evolving around these, especially when sealed classes come into play. So a rule of thumb, for example, that has been published by Ben Evans is that even though it's tempting to add more methods to these data carriers, like the records basically, if you're going down that route, if you're adding a lot of like new behaviors and new methods to your record classes, then maybe you're actually thinking more about an actual class more than a record. However, again, in my mind, it's very early days for records. And with Java 15, we're going to have sealed classes. So I want to see how everything comes together and see what new patterns we start seeing in the industry and in the community. But at the moment, again, this is a preview feature. So just be aware that these are things that can change in future versions of Java. And it's just great to know that this is coming along, and just be aware of how to use them, what functionality they provide behind the scenes, like for example in the case of record classes, all the things that it does behind the scenes for us. And that's it for this video, everyone. We hope you enjoyed the introduction to these three features that Java 14 is including as a preview. We hope you found the video useful, and don't forget to subscribe to the channel. If you want to see other videos with different content or with new features of Java or other topics that you want us to cover, don't forget to add a comment as well. And thanks for watching, everyone. Have a good one.